I'm Natalia, and today I'm going to talk about how to build identity, payments, and embedded widget solutions when third-party cookies are restricted. Let's get started. Identity, payments, and embedded widgets often rely on third-party cookies. Third-party cookies have been on the web for a long time, and many developers use them in their applications. However, third-party cookies are also enabling cross-site tracking and expose users to security issues such as cross-site request forgery. To protect users, browsers have started blocking third-party cookies by default or giving their users the choice to block them. This means developers should audit their solutions and update it if they rely on third-party cookies. This will help to avoid breakage for users who don't have third-party cookies blocked. We have good news. With Privacy Sandbox APIs, you don't have to choose between privacy and functionality. Why would you want to use Privacy Sandbox APIs? Most importantly, Privacy Sandbox APIs offer robust and enduring solutions. They can ensure your site's functionality remains seamless, regardless of third-party cookies availability. Privacy Sandbox APIs are designed to limit the information that is shared about the user and reduce the scope of potential user tracking. Solutions dependent on third-party cookies may fail when cookies are blocked. Let's take a look at how to detect whether identity, payments, or embedded widgets rely on third-party cookies on your site. If you don't embed any content, don't distribute or rely on cross-site widgets, content, or scripts, and don't reuse the same session cookie across multiple sites, there is a chance you don't rely on third-party cookies. But today's web is composable. You probably don't implement everything from scratch. And most external identity and payment solutions rely on third-party cookies. So it never hurts to double-check. The next step is to ensure that all users get the same experience, whether or not third-party cookies are available. The best way to do so is to go through the user flows with third-party cookies disabled. To disable third-party cookies in Chrome, go to DevTools, open Privacy and Security panel, go to the Controls tab, and enable temporarily limit third-party cookies. Another way to disable cookies is through Chrome flags. Navigate to Chrome flags in your browser's URL bar, enable the Test Third-Party Cookie flag, and you'll find other useful flags that can help you to fine-tune your browser configuration for testing purposes. Now that you're all set up for testing, let's go through some user flows that commonly rely on third-party cookies. Let's start with identity. Here is a checklist for you to go through. Can the user create a new account? Can the user sign in? Do personalized sign-in buttons work? Does the sign-in status persist when they navigate to other related domains? Can the user sign out? Do they remain signed out when navigating through the site? Can the user recover their password successfully? Remember to check these flows for every third-party identity provider you integrate with your solution. All right, identity is checked. Let's move to another essential component of the online experience: payments. Here is a checklist to go through with third-party cookies blocked. Can the user check out with third-party providers, such as Pay with Example Provider? Can users add, update, and delete payment methods? Do users see their saved payment methods when making a purchase? Do personalized payment buttons render as expected? Can the user complete purchases even if the personalized button doesn't display the preferred payment method? Does your payment fraud detection work as expected? Do users have to go through extra steps? Can your software still detect suspicious patterns? Every solution is unique. You may have an embedded widget that relies on third-party cookies outside of identity and payments use cases. It's always a good idea to test your site. Here are some other common examples to check. Can your user access chat widgets? can they resume the chat session if they navigate to other pages and domains and back? What about social media? Can your users comment, like, repost? Can your users access content, for example, with an embedded player? Can they access premium content if they have a subscription? Do data dashboard widgets load correctly? Does the dashboard display all the data users expect to see accordingly with their saved preferences? Can users navigate between different sections of the dashboard? Think of any other embedded widgets. Maps, scheduling, contact forms. Do they all work as expected? Does your solution have another creative embedded widget? Tell us in the comments. But what is actually happening under the hood? Let's take a closer look at the context pattern behind these examples. Let's go back to the example flows we've discussed before, like payment buttons or chat widgets. These flows are often implemented as embedded widgets or scripts. It doesn't matter if the widget or script is provided by a third-party company or if it's your company that implements and uses the widget. If a widget is embedded on a site different from where it is hosted, it is considered third-party. The cookies set within a widget that are associated with the widget's domain and that are embedded on a different site are also third-party. Of course, if the widget is hosted on the same domain as the page that embeds it, cookies set by the widget are first-party. A third-party script can also set a first-party cookie. For example, if a script from thirdparty.example is embedded on site.example, it can set a cookie associated with site.example using document cookie property. This cookie will be considered first-party within site.example and won't be sent with network requests to thirdparty.example. Now that we know what third-party cookies are, let's take a look at what happens if they are not available to the user. Imagine you have two sites, site.example that embeds a third-party widget or script, and provider.example that provides embeddable content, scripts, or widgets. When the user visits site.example, they see its address in the URL bar. It means that the user visits site.example in a top-level context. Site.example embeds a widget provided by provider.example. This widget can be anything really. For example, a payment form, a user login, a fraud detection script, or simply a weather widget. Imagine streaming.example is a content provider. The user visits streaming.example in the top-level context. When the user signs in streaming.example, writes a cookie storing the user session. The signed-in user has a subscription, so they have unlimited access to premium content. Streaming.example distributes a player widget, which other sites can embed. Now let's take a look at a concrete example. Say, a famous blogger uploads a video on streaming.example. Only users with a premium subscription can access the video. They also embed this video on their personal blog.example site. Then the user who signed in on streaming.example and has a premium subscription is now visiting blog.example. To grant access to the user, the streaming.example player widget needs to validate their subscription. For that, the streaming.example widget needs to read the cookie that was set in the top-level context when the user visited the streaming.example site. Now, here is what happens if third-party cookies are not available. The widget is embedded on blog.example, which is a different site than streaming.example. This means that the cookie set in the top-level context of streaming.example is a third-party cookie to the widget. The widget cannot access the cookie, and the user wouldn't be able to access the video. This happens because the user is currently visiting another site, and the streaming.example site is now in a different, embedded context. There can be other cases in which a widget or script needs to write or read a cookie in an embedded context. For example, to validate user identity, check their preferred payment method, or update settings. Remember, if the widget is embedded on a different site than it's hosted by, cookies are treated as third-party. When third-party cookies are not available, they won't be included in the requests originating from a site different than the one the user is visiting. So, the embedded widget won't be able to write or read an unpartitioned cookie. Whatever information the cookie stores, the widget won't be able to access it. And that's how some user flows may be disrupted when third-party cookies aren't available. Here is where Privacy Sandbox APIs can help you ensure support for those users. Let's walk through some of them. One of the APIs we have for you is cookies having independent partitioned state, or CIPS. But before we begin, let me introduce the concept of unpartitioned and partitioned storage. Unpartitioned storage is the storage as we used to know it historically. It lacks isolation. If a site writes data into unpartitioned storage, it can be accessed by the site in any context, regardless of whether the data was set in a top-level or embedded context. For example, both the widget embedded on site.example and another site.example would be able to access the same unpartitioned storage if third-party cookies are available. Partition storage is isolated. The data in partition storage is associated with the exact context it was set in and cannot be accessed within a different context. With this knowledge, we are now equipped to understand CIPS. Let's take a look. If you don't need to share the data beyond the pair provider.example and the site.example, add the partitioned attribute to your cookies and keep them isolated. Partitioned cookies introduced with CIPS are double-keyed by the widget provider and the embedding site. CIPS live in partition storage with a separate cookie jar per top-level site. The cookie jar will only be accessible from the same context, the widget and the site embedding it. It won't be accessible by provider.example when it is opened as a top-level site, or provider.example when it is embedded on another site.example. Partitioned cookies are useful when the data doesn't need to be shared outside of the widget embedder context. For example, for chat widgets or payment dashboard site-specific settings. CIPS is supported by most major browsers, and other browsers are dedicated to shipping CIPS as well, and they are currently working on it. If you do need to share cookies between sites, there are other options. Let's take a look at related website sets. For example, if you own multiple related sites, you can declare relationships between them using related website sets. Within a set, browsers allow limited third-party cookie access. Related website sets are useful if you own multiple sites that rely on a service that you also own. It can be, for example, an in-house identity service, or perhaps something like a payment link service that resides on a different domain from the main solution. You can declare a related website set by creating a pull request to the related website sets JSON file in GitHub, where the canonical related website set list is hosted. Related website sets are currently supported only by Chromium-based browsers. If you distribute a solution that other sites rely on, there are other APIs that can help. Let's take a look at the Storage Access API. When third-party cookies are blocked, your embedded widget doesn't have access to its own unpartitioned storage by default. One way to fix this is to prompt the user to grant storage access. You can do so by calling the Storage Access API's Request Storage Access method. With the Storage Access API, the widget can prompt the user to grant storage access. With user permission, the widget can access unpartitioned storage and will load as expected. The Storage Access API can be useful in many cases where the user has previously visited the widget provider as a top-level context. For example, if the user has previously logged in with your identity provider.example and the identity provider.example widget needs to verify user identity when embedded on another site. Or the user has set their preferred payment method with your payments provider.example. Then they want to pay with their preferred payment method on another site that embeds payments-provider.example widget. Storage Access API works across devices and latest browser versions. Another API that can support the functionality of your solution without third-party cookies is Federated Credential Management, or FedCM. With FedCM, users can sign in on sites using account information and credentials from identity providers, companies that have deep expertise in user identity. FedCM lets you customize the user identity experience. For example, you can choose between different UI modes or configure the user prompt to state exactly what user data is requested. Additionally, an active FedCM session serves as a trust signal for the Storage Access API. That means that when storage access is requested, your widget will automatically get access to its top-level unpartitioned storage. This accounts for a more seamless user experience. No additional user prompt is required. FedCM is a great option for identity, payments, and content providers. FedCM is not baseline because it's a new feature that is not yet supported by some of the widely used browsers. However, other browsers are currently actively implementing FedCM. We've covered a lot of technologies, but now it's time to get some real-world perspective. Let's ask Dipti, a product specialist on Google's Privacy Sandbox team, who constantly connects with industry leaders and knows exactly what is driving the market. Hey Dipti, we are eager to hear your insights. What's going on in the industry?
Thanks, Natalia. Happy to be here. Industry leaders in identity, payments, and embedded widget solutions understand how important it is to offer both privacy and a good user experience to their users. Identity, payments, and embeds may rely on third-party cookies. This is suboptimal for user privacy and can impair user experience where third-party cookies are unavailable. The number of sites and services that use Privacy Sandbox APIs keeps growing and includes KG Media, NetID, Ori, PayPal, Sesnem, Shopify, Times Internet, Tray, and many others. These companies are reporting positive outcomes from their adoption. Let's explore how specific industry leaders are leveraging Privacy Sandbox to achieve their goals. KG Media, one of Indonesia's largest media groups with publisher networks like Campus, reaching over 70 million monthly active users. Recognizing the growing importance of user data privacy, they integrated related website sets and updated their Google Identity Services implementation to support FedCM. Their integration of related website sets ensures consistent personalized user experience within KG Media's related sites. Complementing this, their adoption of FedCM for Google Identity Services provides a more privacy-respecting way for user authentication. This forward-thinking approach not only maintains a seamless user journey, but also reinforces trust with their vast audience. Next, I'd like to talk about Sesnem, a leading European technology company, publisher, and identity provider, reaching over 90% of the Czech population. They have integrated FedCM to allow users of the e-shops operating on their partner's platform to sign in using their Sesnem account. In addition to an improved user experience and a consistent identity flow, regardless of third-party cookie availability, they achieved a noticeable increase in user sign-in rates on their advertiser network. This demonstrates how privacy-respecting solutions can positively impact user engagement. Here's another example of Tray, an e-commerce CMS provider from Brazil. They adopted a dual strategy. They transitioned third-party plugins to chips to allow them to function properly while limiting the potential for cross-site tracking, and updated their internal applications to all be first party to each other. Trey prototyped and validated a solution with chips in a 15-day sprint with 2 developers. With this implementation, they are ready to transition to a durable solution and provide support for more users across browsers. These examples from various sectors like media, payments, and e-commerce platforms really highlight the momentum we are seeing with Privacy Sandbox adoption. This isn't just about a cookieless future. It's about creating a better, more trustworthy online world in the present.
Thank you, Dipti. Whoa, it looks like companies around the world are preparing for third-party cookies restrictions. They demonstrate how privacy and great user experience go hand in hand. Let's sum up what we've covered so far. We've talked about what third-party cookies are, which solutions don't rely on third-party cookies, which identity, payments, and widget solutions might be using third-party cookies, and how to test your site. Most importantly, we've covered alternative APIs that can help you support more users. And lastly, we saw how industry leaders adopt the new approach. Now it's time to test your site and transition to the new approach. Together, we can build a thriving internet that safeguards user privacy. Join us on this journey at privacysandbox.google.com. Check out our identity, payments, and embedded widget guides for more tips. If you want to learn more about each particular API, take a look at the developer documentation. Thank you for joining our identity, payments, and embedded widget session. You might also be interested in other I/O sessions, like what do cookie changes mean for web developers and reshaping user authentication and identity verification. Check out the links in the description. And now, happy coding!